Alright, here we are graphing trig 3. So now we're dealing with the cosine trig function, okay? Cosine of theta. So, just like with the sine, it's the same process, okay? The idea here is that we are graphing now. Remember, the cosine is the x value, but on the x-axis, we do the angles around the unit circle, right? All these angles around the unit circle, or radians, are represented by the x-axis. The y-axis is then the value of the cosine. And remember, the cosine is all the x values here. Okay? Well, technically all around. So that's what it's based off, this x value here for 0 and 2 pi. The x value here, the x value here, here, here. And those are negative, that's why it goes down. Okay? Then we come back to positive again. So, just like with the sine, there are 5 points we want to deal with. The first and the last, notice that these ones are at the top of the amplitude here. Right? That A amplitude. Then you have the middle one. For sine, they were all on the midline. Okay? For cosine, they're not. The first and the last are above, and then the middle one is below in the amplitude. Okay? And then the two middle pieces that make the 5 are on the midline. It has to do with the unit circle again, right? We started out at 0. And what's the x value of 0 here? Because we went out there, it's 1. Okay? Then we go around to 90, or pi halves. Now our x value is 0. We go around to 180, or pi, and it's negative 1. Down here to 270, or 3 pi halves, and we get the 0 again. And then back here for the positive 1. Okay? At 360, or 2 pi. So it's those main 5 points again that you're talking about. And then the same rules apply for everything else. The midline k, that just moves that up or down. The whole shifts the whole thing vertically. And k, right, we just use that midline. The b, the number with the x or the theta, that b we use to find the period. Remember, the period is from where we go from the top and then back up to the top. We find it by going 2 pi divided by b. Don't worry about the frequency. Then the amplitude is that number there. It tells us how high up, how high the peaks are, how low the troughs are. Okay, all of that. And it's just that amplitude. So let's get going on this. So these first ones, notice, there's no number here, there's no plus a number. So my k is 0, and my period is 2 pi, because that's our typical period. Same with number 2. K of 0, period of 2 pi. Okay, so I know my midline is here. Midline is here. Okay, now what I know is that on that midline is my 90 degree, or pi halves, and my 270 degree, if this was a unit circle. So I know at 90 and at 270, I have those points on the midline. At 90 and 270. Now, the first and the last, I need to know my amplitude. Amplitude of 2 means that it shoots up to 2. And it ends up at 2 at 360. Okay? And at 180, it goes down. So it looks like this. Okay, on number 2, my amplitude is 4. So I'm going to start clear up at 4, then go to 90, then go down to 4 at 180, then back to the midline at 270, and then back up at 360. So it looks something like that. Okay? Alright. So, let's take a look at the rest of the problems. So it's always a good idea to draw that standard parent graph for cosine, which would look like this. Amplitude of 1 at 0, down to the midline at pi halves, below amplitude at pi, midline at 3 pi halves, and then at 2 pi we finish our period. Okay? So there's our typical cosine, our parent graph. So now we still have a k of 0, period of 2 pi, because there's no numbers here or here. And my amplitude is 1/2. So now I start at 1/2. Then my 90, we didn't move the midline, so that stays the same. Then go to 1/2, down, then back to the midline, then up 1/2. So just kind of a shallower one there. For 4, we've got an amplitude of 2, k of 0, period of 2 pi. So I'd go up to 2, but my pi halves is back at the midline, then down to a pi, 3 pi halves, back to midline, and then back up. And it would look like that. Well, now let's deal with that midline, okay, see how that affects things. So, once again, draw our parent graph for both. It's always helpful to have that to reference, because those are those 5 points that will help us. So, amplitude of 2. Now this time my midline is shifted up 2 because it's a positive 2. So instead of being right here, it's shifted up to 2. Okay, the points to stay the same are going to be this at pi halves, that's always on the midline, and 3 pi halves. And I shouldn't say, oh, well, yeah, it's always on the midline, 3 pi halves. Unless we have a, if our period changes, and that could adjust things. Okay, it would just move those lines, those points, so they'd be like further in or stretched out further. That's really the only change. Okay, so now our amplitude is 2, and our period stays at 2 pi because we don't have any number here. So our amplitude of 2 means from that midline I now go up 2, and then up pi I go down 2, and then at 2 pi I go up 2. Well, my parent graph was shorter than it should have been, huh? So there we go. There's our new graph. Okay, number 6, same idea. Now I've got a midline of -1, an amplitude of 1/2, and my period stays 2 pi. So my midline shifts down to -1, which means that pi halves right here shifts down here. 3 pi halves shifts down here. So right here and right here. Then from here, I begin only half up with my amplitude. I end only half up, and in the middle the pi goes down. Okay? Alright, same type of stuff. Okay, amplitude of 2, midline shift of 2, and period of 2 pi. So my shift is up, my midline is right here, which means at 90 degrees and at 270 degrees, my points are on there. My amplitude is 2, so from the midline I'm going up 2 to start off, then down, and then at the 180 down 2, and then at 360 back up. It looks just like that. Number 8, K shift, vertical shift is down at -2, so K equals -2. Amplitude of 3, so at the beginning I'm shooting up 3, and at the end I'm shooting up 3 from my midline, and then at 180 I'm shifting down 3, and then as my 90 and 270 stay on that midline. Looks just like that. Not too shabby then. Alright, now we're going to add some period changes, okay? Remember, it's going to crunch it in or stretch it out. So let's draw our... See, now notice it's going 60, 120, so it's changed the way we've numbered. But our parent graph is always numbered the same. So it looks like it's count by 30, so that would be 90. Okay, 180, 270, and 360. graph's a little different, just because of my coordinate plane was a little different. Now, our amplitude is 1/2, so we know it's going to be a little shallower. Our midline, k, is 1, so we bump it up to 1 for our midline. Now, we can't just transfer the 90 and the 270 because of this period. Remember, that's b, and it's 2 pi over b for our period. So my period is 2 pi thirds. Okay, or 360 divided by 3, same idea. Okay, so it would be 120 degrees, right? That's what 2 pi over 3 is, 120 degrees. So that means from start to finish, I'm only at 120. Okay, so I start on the y, but from my midline I have to go up 1/2. Okay, so I'll start right there. And then I'm ending at 120. Okay, so it's kind of crunched it in quite a bit. So my ending would be up there at 1/2 as well. So right here and right here. Okay, and also then we go halfway in between, because 180 is always halfway in between. So halfway in between I go down 1/2. And then, halfway in between here is on the midline. Halfway in between here is on the midline, representing those two. And there's my graph. So when you have to adjust that period, you're basically just taking those 5 points, remembering that first and last are on the same, the middle is opposite, and then between those two is on the midline. Okay, so number 10. So taking a look at this one, here's what, trying to draw the parent graph. They didn't give me much space, did they? So start and end, and down here, so in betweens would look like that. So really short. They they go clear up to 12 pi. That's because of this. That's 1/4 times theta. So my b is 1/4, so I go 2 pi divided by 1/4, which is really 2 pi divided by 1/4. So we go 2 pi times the reciprocal, which is 4 over 1. Get rid of the over 1. 4 times 1 gives me a period of 8 pi. Okay, so we're ending clear out here. Beginning here still, ending clear out here. But we've got to check our other stuff. Okay, we are got an amplitude of 1/2, and we're midline shift to 2. So up here is where my midline is. Okay, but then we're only going 1/2 above and below. So my beginning is 1/2 above that. My ending, which ends at 8 pi, is 1/2 above. So halfway between 0 and 8 pi is going to be 4 pi. So right here, I go 1/2 below, my amplitude below. Then between those two, it's going to be where it hits the midline. So 1/2 of 4 pi is 2 pi. And from 4 pi to 8 pi is going to be 6 pi. So that's where we hit our midline to get those 5 main points. And then we can draw our graph right there. Alright. So let's take a look at the last two. So let's draw our parent graph. Pi halves, pi, 3 pi halves, 2 pi. 2 pi. Wait a minute. Whoa. Having issues here. 3 pi halves on the midline, 2 pi. So 0, pi halves, pi, 3 pi halves, 2 pi. So now let's see what we've got. So an amplitude of 2, vertical shift, midline, -2. So down here, -2. And then 4, so 2 pi over 4. So 2 over 4 becomes 1/2, so pi over 2 is my period. Okay, that's a really small period. So within the 90 degrees, we're going to have our whole graph here. And our amplitude is 2, so from my midline, we're going to start 2 up. We're also going to end 2 up at pi halves. Okay, so then halfway between pi halves would be pi fourths. right? Right here. So that's going to be 2 down, so right there. Then halfway between, we just kind of guesstimate. And so we got a really skinny one. And if we really wanted to, we could just keep doing that. And we could do a lot of periods, huh? And that's what it would look like. But we just mainly need 1 period at least. Alright, so number 12, amplitude of 1/2, midline shift of 2, so bumping it up to 2, and then pi half, so we have 1/2 pi, so 2 pi divided by 1/2, so basically 2 pi times 2, or 4 pi would be our period. So from our midline, we're starting halfway up, and then at 4 pi, that's where we end, so it would be halfway up. So halfway up, because my amplitude is 1/2. Cut that in half, which is 2 pi, we go half down. And then on our midline, we cut them in half, and we get it like that. And there we go. So there's graphing cosine, which is very similar to graphing sine. Use the same process, the same 5 points, just kind of slightly different area. And there we go.